Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, on to the next lesson, lesson 2.2.4. We are going to learn about multiplication and how it is repeated addition. And we're going to use some of our concepts with Cecil and the tightrope and doing our diagrams to help illustrate this concept. Before we get started on it, though, there's this little kind of an activity that I like doing with students. I've done it over the years, and it kind of fits in with what we're doing in this lesson, so I decided to attach it here. You don't necessarily have to draw this down. You can just watch it. That's not that important, although you might want to have a pencil, paper, and jot a few things down to solve the problem. So basically what we got here are two tin cans. They do not have any markings on them, so these are not graduated measuring cups. The only way to be certain that you have the precise amount is to fill this cup to the top. And when you do, you'll have 5 total cups. When you fill this one to the top, you've got 2 total cups. And your task is to figure out a way. If, let's say, you were out camping somewhere in the wilderness, and you brought your book of wonderful camping recipes, and you needed like a cup of water or 3 cups of water or 4 cups of water, but you don't want to bring 5 different sized cups. How could you use these 2 to get these quantities? Okay. Now, here's one of the rules. To get 1 cup, you can't fill up the 2 cup and then pour it off an eyeball about the halfway mark. These are not graduated. There are no lines. So there's no way to know that you're exactly getting 1 cup and that you're exactly pouring this off by half. So all you can ever do is fill up a cup or completely or pour off the cup. Like you could dump it out or you could pour it into here. For instance, if I take 2 cups here and I pour it into there, now I've got 2 cups in this 5 cup container. I'll know that it's 2 cups because I filled this one up and put it in there. Conversely, if I filled this one up with 5 cups and then poured as much as I could into here, I would then have 2 cups in this one and 3 cups in that one. See where I'm going with that? So your task, go ahead and pause this. See if you can figure out the combination of moves that it would take to get 1 cup, 3 cups, and 4 cups. Obviously, we're not going to find 2 cups and 5 cups because all you got to do is fill it to the top, and that's too easy. Okay. So when you feel ready, go ahead and unpause, and you can watch how I decided to do it. And there are probably a few different ways you could do it, so my way is not going to be the only way. All right, let's start with the 1 cup. The way I thought of it was, if you fill this up, fill up the 5 cup, and then you pour that into the 2 cup, and then dump out the 2 cup, and then you've got 3 in here, and then you pour 2 cups into the 2 cup again. You can just dump that out, and now you've got only 1 cup remaining in the bottom there. So 5 cups, take away, pour off the 2 cups, then pour off another 2 cups, and you've got 1 cup. To get 3 cups, I already kind of mentioned that when I was describing everything. If you filled up the 5 cup and then poured off exactly 2 cups, then you could dump this one, and you would have 3 cups left in this one for your recipe. And the 4 cups, how could we do 4 cups? Oh, well, yeah, okay. So you fill this up completely, dump it into the 5 cup, fill it up again, dump it into the 5 cup. You'll now have 4 cups in here, and you won't need those lines for measuring. Okay, so it's in this kind of an idea where we're going to be going today, where we're going to try and create different distances or measures or numbers by using repeated addition or repeated subtraction. Okay, so in the previous lesson, you created expressions to help Cecil cross the tightrope. For example, when the tightrope was 16 feet long, you could have written an expression such as 7 plus 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 -5 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 plus -5. when a calculation involves adding the same number over and over, as this one does, is there a better way or a shorter way that we could write that expression out? Today we're going to consider this as we continue to write and simplify expressions. All right, so here's the direction. I'll do some highlighting here. Cecil, the tightrope walker, introduced in problem number 31 of this chapter, still needs your help. He wants to cross a rope that is 6 feet across, but he is only going to use lengths of 5 and 8 feet. Okay, so this is kind of like that cup problem where you need 6 cups, but you've only got a 5 cup and an 8 cup. How are you going to make that work? Okay, so your task is to try and figure out 2 different ways that Cecil could get across. Now, remember the nature of Cecil on the tightrope. He is allowed to walk beyond and then come back. Okay, so he's not going to fall if he goes beyond it. But your task is to get him to walk using only 5 and 8 feet steps, a total of 6 feet, but either walking forward or backward, or I guess left or right, however you want to think about it. Okay, so see if you can figure out a couple different ways, and I'll show you the ways that I figured it out. All right, so let's start with this guy right here. I chose to go 8 plus -5, which is 3 feet, right? And then 8 plus -5 again, which is 6 feet. So if this is the tightrope, here's the starting point. This is the end point, which is 6 feet later. You would go 8, which would take you across, but then 5 back, puts you at the halfway point, which is 3 feet. Then we go another 8, and then another 5 back, and where do we stop? Right at the end of the tightrope, which is 6 feet. So 8 plus -5 plus 8 plus -5 is equal to 6. Second way that I chose to do it, I was really stretching my screen here, but I couldn't think of any other way to do it. I suppose maybe you came up with a way that was shorter than this one that's different than that. But I ended up having him go 5 plus 5 plus 5 plus 5 plus 5 plus 5, which is essentially, what is that, 6 times? So that's 30 feet. And then go backwards 8 feet 3 times, which is 24. So 30 plus a -24 leaves you at 6. There you go. Different ways of exercising and illustrating how repeated addition, repeated subtraction can get you from one point to the next using this Cecil kind of a model. All right, so Cecil moved across the rope, shown at the right. Showed 2 different ways to represent his move with number expressions. The one obvious way is to say 6 plus 6 plus 6 plus 6, right? And 24 feet to get across. But what this lesson is getting at, it is called multiplication as repeated addition, is that rather than write that out as 6 plus 6 plus 6 plus 6, what if we showed it as 4 times 6? This means the same thing, right? 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. Then it's just a lot easier to write 4 times 6 is equal to 24. All right, so that's the essence of what this lesson is about. So go ahead and do the exact same thing with problem number 69. Write it in 2 different ways, the repeated addition way and the multiplication way. It would be good, by the way, if you copy these diagrams down. One of the things I stress with students is when you're doing work in your journal, eventually you're going to get to a point where we are going to take a test, and it'd be good to review the work that you did in preparation for the test to make sure that you understand everything. If you're really sloppy in your journal and you're not writing down at least a part of the problem or the diagram that goes with the problem, it's really hard to look at it and understand why you wrote what you did 2 weeks ago. So copy these diagrams down and then write in the answer, okay? And so here it looks like that's going to be 7 plus 7 plus 7 plus 7 plus 7, right? For a total of 35. Or how many steps did he take? 5 steps that were 7 feet each. So 5 times 7 is also 35. All right, so when adding the same number several times, multiplication can help. For example, if the tightrope walker moved to the right 3 feet, 3 feet, 3 feet, and 3 feet, it's so much shorter to just write 4 times 3 instead of 3 plus 3 plus 3 plus 3. So Note that the parentheses is one way that you can show multiplication. You can also show it with like 4 times 3, putting the dot or the multiplication x. But remember, CPM is trying to phase you out of that multiplication x thing, but you can still use it sometimes if we're not dealing with algebra. Okay, so go ahead and write this as a multiplication statement. What is 2 plus 2? Copy down plus 2 plus 2 plus 2 plus 2, and then write it again as a multiplication problem. Your answer is 10, right? How many times did you add the 2 together? 5 times. So your answer is going to be for this 5 times 2, which would give you an answer of 10. All right, imagine that Cecil in the tightrope walker starts at point B now and is walking backwards toward A. How would you write this sequence of steps? Can you write that in 2 different ways? Go ahead and draw that diagram and write it 2 different ways like we did on these problems. All right, so since they're negative steps, now we're going to say -3 plus -3 plus -3 plus -3 plus -3, which is the same as 5 times -3, ends up moving you back 15 feet. So it's like you went backwards, so it's -15 feet, right? So he ends up 15 feet from the end, somewhere closer to A. To represent 2 times 3, Chad drew the diagram at the right. Okay, so you see how that's 2 times 3? So it's a different kind of a diagram than Cecil and the tightrope. Once again, I kind of like these guys better. I just think they're easier to work with. So do you understand why we have 2 times +3 there? Okay, so Chad would like to draw 5 times -3. Can you help him out? Go ahead and draw what you think that would look like using similar strategies with the integer tiles. And then what is the value of this expression? Go ahead and pause it, draw it the way you think it should be drawn, and then unpause it. You can see how I did it. All right, so did you draw something that looks like that? You've got 5 groupings, 1, 2, 3, 4, 5, with 3 negatives in each grouping. So 5 times -3 is -15. Okay, so I don't know, which way do you think is easier? I much prefer doing this than doing the diagram, but to each his own. You know, maybe you like the diagram more. That's okay too. All right, so the 2 equal expressions, 2 times 3 and 6, can be represented with a diagram like this one right here. You see how they're parallel to each other and they both have the same starting point and the same ending point? Okay, so this is one way that you can show like 2 expressions are equivalent to each other. So what does 2 times 3 plus 5 mean? So what is the value of this expression? Describe it in words, and then draw a diagram of it. Do the same for problem B, but this time it's going to be 2 times 3. Then you add the 5 in. And then for part C, how are these 2 expressions similar? How are they the same? How are they different? What's going on here? This is a type of problem that gets you into the order of operations, where you start to understand why you need to, if you want to have addition be your priority, you've got to put parentheses around it. So you change this 3 plus 5 to be equal to 8 before you could multiply times 2. Without having the parentheses around the 3 plus 5, you're only going to multiply 2 times the 3, not also times the 5. Okay, so go ahead, answer questions A, B, and C, draw your diagrams, and then unpause when you're ready to move forward. Okay, so what is the value of this expression for A? Well, basically what it means is you're moving to the right 3 feet, then 5 feet, and then you're going to do that motion again. You're going to do it a second time. So you'll do the 3 feet and the 5 feet combined 2 different times. And the way that that would look would be like this. So the total value is 16, right? Because you're going to do a 3 plus 5, then another 3 plus 5. So it's essentially 2 times 8, which is 16. What about this one? What does that mean? 2 times 3 plus 5? This one means that you're moving right 3 feet 2 times, then you're moving right 5 feet for the last step. So how would that diagram look? This is going to be 11 feet long because you're going to take 2 times 3, which is 6 feet. You have to move that first, and then the 5-foot leap is the last one. So 3 plus 3 plus 5 is like 2 times 3, or 6 plus 5 is 11. So how are these movements the same, and how are they different? Well, we both have 2 sets of moves, right? Here you had, the 2 steps of 3. Here you had 2 steps of 3 and 5. But what's different is that the distances are different. All right, so this is a fast lesson. This is how I would like our lessons to go, a little bit quicker than the 25 to 30 minute variety, but this is the big idea, okay? And I'll spend a couple minutes talking about this big idea. As it states in the lesson, the name of the lesson, multiplication is repeated addition. And so we can make our expressions, or mathematical expressions, easier to write and shorter if we, instead of just writing everything as pluses and minuses, if we incorporate multiplication, okay? So 5 times 4 literally means 4 plus 4 plus 4 plus 4 plus 4. You are adding the number 4 together 5 times, and you get an answer of 20. 3 times -2 literally means -2 plus -2 or plus -2, because you are moving -2 3 times. So 3 times -2. This also, by learning this lesson and understanding the logic of it, helps you understand a rule for multiplying positive and negative numbers together. A lot of times students get confused. If it's 3 times -2, is that supposed to be a negative or a positive answer? As opposed to -3 times -2, which we'll get to multiplying two negatives together later. But here you can kind of see why your answer has to be a negative answer anytime you multiply a positive times a negative. Because when you, like if I use this model here for negatives, right, can we all agree that you've got a total of 6 negatives, 3 groups of them, so -2 times 3 is -6. And with the 5 times 4, when it's a positive times a positive, we know that's a positive answer. There's never been any issue with that. All right, so keep this in mind. We got a little bit of a glimpse of order of operations here and why we do certain things in the order that we do them. We'll talk more about that as we get into future lessons. Why don't you go ahead and transition to homework, and good luck with that. Make sure you show all of your work and draw your diagrams. All right, take care.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,